Okay, Bismillahirrahmanirrahim. This is an example of regression. Let's say we have two variable, independent variable x and dependent variable y, and let's say we have these values for variable x, which is independent, and these are the values for variable y, which is dependent on x. Okay, so if we want to create a regression, or we plot its equation, so in excel we can do it very easily. Let's say we create this scatter plot. Okay, now this is the representation. These are the different points. This is this x-axis represent variable x, independent variable, and the y-axis represent variable y, and these are the points. Now let's say we create a model for these points. This means that, like, which equation, which mathematical model can represent these points. So just right click and add trend line. Now this is the different functions provided by uh, Excel for creating models for these points. So the default selection is linear equation. As I had already told you, we will have a detailed discussion on linear and nonlinear models, but the default is this. And let's say we display the equation on chart. So if we are interested in this linear model, this means that these points can be most closely represented through this line. So although this point and this point, this point and this point and this one, these are not accurately passing, the line is not passing through these points, but this is the most suitable line which closely represent these points. So the model that is created for these points is y is equal to 2.4672x plus 1.4836. Okay, so this is the linear model. And if we are interested in logarithmic model, so okay, so logarithmic model cannot be created as we have 0 in this number. Okay, no problem. So we can stick with the existing linear model. Let's say this is linear model, and let's say we display equation on the chart. So this is the linear representation. This means that this 1.4836 is the y-intercept, as we have normally in the line equation, and 2.46 is the slope, and x is the independent variable. And using this equation we can get value for the dependent variable. Now this model means that in the given scenario we have just these few values, but we can calculate the value of dependent variable for any value of independent variable using this equation. So from these existing samples we created this model, and now this model can be used for computing any value of y if the value of x is given. Okay, these are the samples, but from these samples we have created this equation. Now if we change these points, so our model will change accordingly. For example, let's say we convert this to 20. Let's say I close this, and let's say this is 20. So now the equation is changed to this one. And in our previous model most of the values were closely matching to the points. Let's say it was this one, so it was. And if we add another component, uh, 1 minute, a trend line, if we also display the equation as well as the r square on the chart. Okay, I think we had displayed it multiple times. 1 minute. Okay, the equation is already displayed, and now we also try to display the r value. Okay, this is the r square value, and as we had discussed that the value close to 1 means that the model is accurate, and if the value is becoming closer to 0, then this means that the model error is more. Okay, let's say we changed this 10 to 20, and now observe this error of the model. So now it is 0.97, and when I change it to 20, so it is zero point 0.6. It means that now the model error has increased, and you can observe this from these points. Now the model says that the point should be here, but the actual point, one is the prediction and one is the actual value. So in many values, the error has been increased. So now if I change, let's say this 13 to 23, so the error will further be increased. Okay, now it the model error is zero point 0.5. This means that our model accuracy is decreasing. Okay, so this like creating a model for these points is called regression, and from this regression is actually a representation of some system through any model through which we can predict the output for any arbitrary input. Okay, so thank you.